Okay, I think everybody's here. I didn't see people joining. So hello all. I'm really excited to be doing this talk today, Unreal Online Multiplayer Tips and Tricks. My name is Mohammed Musa. I'm a junior network programmer at Hixworks CI Game Studio. This is my second time attending the NotGDC event, about my first time that I do a game dev related talk. So I'm really excited. Thank you everyone for coming. It really means much to me. Also, thanks to everybody who organized and made this possible. It wouldn't have been possible without you, people at NotGDC. And yeah, let's start. So introduction and motivation. Multiplayer games are great and fun. I'm sure like we all here love playing multiplayer games, and since we're here today, we want to make sure that they keep being that way. It's really easy to mess up things if you're starting with multiplayer and you're not aware of what the practices are, whether they are good ones, whether they are bad ones. You should really be aware of them so you know how to do things properly. And since we're here today, we're here to discuss the tips and tricks that should hopefully move us to a whole nother new level in terms of networking in Unreal Engine. This talk is heavily based on the article that I released a few days ago. You can find a link to my website. It's also found on my Twitter account. Okay, so tip number one: be aware that blueprint only multiplayer is fine, but is limited. Anyone who starts doing Unreal Engine, whether it's multiplayer or none, you're probably going to start with blueprints. The fact that Unreal Engine itself can be overwhelming for starters, that's very normal. But you should be aware that blueprints are really limited in terms of multiplayer. And we are going to be going over the tools that blueprint lack. So one of them is replication graph. Replication graph is a kind of a system that Epic designed for their game Fortnite. It's the kind of system that aims to replace the regular relevancy system. And if you're not aware how the regular relevancy system, basically, in a few short words, it checks for stuff on tick, how actors are considered for replication, for example. And you probably will tell yourself, okay, this is not probably the most performant way. Things can be enhanced there, and that's why they did this, especially that they have too many connections in one game, about like 100 players in one game. So that makes a lot of sense. This is not the kind of tool you would be using in every project. Well, for example, me, myself, it's not my wheelhouse. But yeah, it's really, and as far as I know, with with Epic's new replication system called Iris that just dropped in 5.1, this system is going to be replaced by that new replication system called Iris. Another very great tool is custom network serialization for types. So basically, this is not something you would be touching, of course, if you're starting with multiplayer, but just to know that in C++, you are able to custom or serialize types the way you want. So for example, you can just like take two properties and say, I want to replicate those two properties always together. So they always replicate. Whether one does not change and the other, whether one changes and the other does not, they will replicate together. And you might like ask yourself, why would I do something like this? You would do something like this if you want to make sure that you always, or you never end up in a state client side that never existed server side. And if you end up in a state like this, you might get to an undefined behavior that might be unrecoverable afterwards. And this is something you're not able to do in blueprints. Another thing that is really the blueprint relax, sadly, is the fast TRI replication. You're probably already familiar with the TRI container that Unreal Engine has, but fast TRI replication is kind of a more sophisticated TRI that is, in my opinion, is much more, it's better used for when the TRI gets bigger in size. So they have some kind of optimizations there, and they also have these very good replication callbacks for client that you can use whenever you add an element, for example, or in a simple TRI, in the regular TRI, you have, for example, to traverse the RI and just check with the old one and know what changed, for example. Blueprint also lacks the very handy virtual methods that you would almost always override in any project you work on. For example, is net relevant for is a very important function that lets you manipulate the way an actor is relevant for a connection. It's simply not exposed to these functions are not exposed to blueprints. Another is on-rip player state, which we'll go over later today. There's also no proper replication callbacks for blueprint properties. So say, for example, you want to listen to when a property replicated to client. You wouldn't be able to do that in Blueprint, considering these callbacks are missing. In C++, you do have them. And you also have an argument. You're also able to plug in an argument that lets you know what the old value was before the replication took place, which can be really useful. Another set of tools that are missing in Blueprint is, for example, is for the fine control over replication conditions. So say, for example, you have this certain property in Blueprint that you're setting, and say you set this value say you have this new value the same as the old value. If it's the same, then you won't be getting a replication callback triggering. And you might say, like, okay, that's normal. I mean, I don't need, if it's not changing, I don't need it. I don't need this kind of replication callback taking place. Well, mostly that's correct. That's a correct assumption. But sometimes you do want them to get called even if the local value did not change. It did not change from the last server set value. And this can happen, for example, if you're doing prediction, which is an advanced topic. You don't really need to worry about this if you're starting with multiplayer. Considering the way properties are set, even in C++, they have this kind of tag. It's called rip notify underscore unchanged, which means that only when this property changes from the last local value, it will be propagated to the client. So, for example, in C++, you can just override that thing and just say, okay, I want it to be rip notify always. Another ability that is missing in Blueprint is to be able to not replicate some properties of a struct. So say you are replicating a struct property. In Blueprint, you are forced to replicate all those properties in a struct. You're not able to miss any to exclude any of them. Where in C++, for example, you are able to do so. And another feature is the ability to replicate sub-objects. And with sub-objects, I mean objects that are not actor components. So the reason you would want to replicate these kind of objects is the fact that these objects are lighter weight than actor components, for example, and you would want to use them. And if you noticed in something that Epic dropped in 5.1 is some kind of a new way to replicate sub-objects, which was really cool and very easy to implement. And the list just grows. So at this point, I assume that you are able to, or you have figured out yourself that you should consider the move to C++. I know that the move to C++ can be overwhelming, especially if you're not coming from a programming background, of course, but just take the time, learn. It's not as hard as you think. Okay, so tip number 2, don't feel afraid to read through the source code. This is probably my favorite and probably one of the most underrated tips that out there. I wouldn't have been able to land the job that I have. I wouldn't been able to do the talk that we have today. I wouldn't be able to write the articles that I write if I was not able to read through the source code. It really helps you understand the engine's infrastructure. It helps you understand what classes you have, where things should be implemented. For example, you have this kind of a actor or a class called player controller, and you know what things should be in there, and you have this kind of a game mode actor which dictates what the rules of the game are, and this kind of rules have to go in there. And knowing about these classes and about these the engine's infrastructure could help you a lot, and also will help you ask better questions. And with better questions, I mean probably engaged in some of the related Discord servers. And I keep seeing questions that are badly worded, and they mainly come from this fact that people are not aware of what the engine tools are, and they don't read simply through the source code. I mean, you could always go and ask. You could always go and check through YouTube or Google and just Google stuff, or ask ChatGPT. I don't know, but you always have to consider reading through the source code, because it's the only reliable way. It's the only reliable source of information that could point you to the thing you want, and could only when you're not able to understand what's going there. I would only advise you to go look somewhere else. Okay. So get to know the game framework objects online-wise. Tip number 3. So in general, you should be able to get to know this game framework objects, not only online-wise, because they will let you know where stuff, as I already said, where stuff should go. It will make your code better structured. It will save you time down the line. It will eliminate the need to reinvent wheels, for example, and it will let you know and better understand how why actors behave the way they do, and how they operate, for example, and how executions go and stuff like this. And when you happen to hit a bug or something, you are better able to debug your own bugs. And this is a table that I copied from my own article that just sums up some of these game framework actors with some of the most notable replication settings. For example, you can notice that game state, player state are one of the 2 actors that have in common the always relevant setting. It means that they will be always relevant to all connections, no matter what. With this, I mean that if you're not aware of how the relevancy system works, there are a certain set of criteria that are checked every time an actor is checked for replication or is considered for replication. And if you have this flag turned on, always relevant, then it will skip all these kind of all these criteria and just jump to the end, just like, okay, this actor will always be relevant to all connections no matter what. And for this simple reason, you could also notice that they have this low net update frequency and net priority, which means they will be less checked for replication. And that's really reasonable, considering the fact they're always relevant. It wouldn't make sense for these values to be really high, like their counterparts. So we have this player controller, for example. It says that it's only relevant to owner, and with this it means that the player controller, for example, this is the kind of behavior you've already met, where on client, only the player controller for that client exists on that client instance. So for example, the other remote machines, the remote clients do not have their own player controllers on your machine. And this is for this simple flag here. And for pawn, for example, it has replicate moving turned on. It makes sense considering pawns are meant to move and stuff like this. Okay, tip number 4. Beware of get player XXX0 static functions. So this is probably the most static functions that I've seen being abused in multiplayer code, like literally everywhere. With those, I mean like exactly the functions that you see. They come with this 0 index as default, and I see like people use them everywhere. These are not like literally just stay away from these functions, even if they make sense sometimes in some certain scenarios. Just keep away from them, and we'll explain why in a second. So first, where do they come from? I've always asked myself, and there's multiple reasons for this. Single player for sure. Anyone who starts with Unreal Engine will probably start doing single player. Will start using these nodes. They make all the sense to be used in single player, so they are fine there. But what is bad, that is they are being persistent to multiplayer, which is not correct. Also local multiplayer, I guess they were made originally with local multiplayer in mind, considering the index. And this is something people would do before multiplayer, and since why they come to multiplayer, to online multiplayer. Also tutorials for sure. You would see people using them, even if the use case is acceptable. The tutorialist does not explain why the use case is valid, or they even just like use it without it being like valid in the first place. So just like keep that in mind. So why they are potentially harmful in online multiplayer? So they are harmful for the simple reason of consistency. These static functions can behave differently based on the context. So for example, in a client instance, in the listen server instance, they will return the listen server player controller. In the dedicated server, they will return the first client's player controller. On the client, will return the client's player controller. We'll probably already figure out that on client it makes sense to return the client's player controller, considering the fact that it's the only player controller that exists on the client. So it makes sense. But in the case of a listen server, say you want some other, I don't know, some other player controllers that is fighting the listen server player, then you're probably with using this get player controller 0 would return the listen server potentially. We'll see that's not always the case in a second. There's a landmine there. And in the dedicated server scenario, it does not make any sense to why you would want to get the first client's player controller. So the landmine I was relating for that happens when you have a listen server environment and you are seamless traveling. What can happen is that the client can connect faster than the server, and it happens to have the index 0 for the client and not the server, and this can be really disturbing if you're not aware of this, and it's really hard to track. A bug that is really hard to track. Since why I always say just like keep away from them. It's like one of the landmines that I was able to figure out and just like see somewhere, but probably there's some other landmines that I'm still not aware of. So just like keep away from these functions and instead use the following safe method, which is called get first local player controller from game instance. You should be aware that this function sadly is not exposed to blueprints. And at this point, you probably should realize this considering we've already said that blueprint is limited in terms of networking. And always keep in mind that there are always other ways around these static functions. So I've put you here the functions or the properties that you should be using. You should be getting these functions or you should be getting these objects based on the context, and they make perfect sense. So tip number 5. Filter client-server execution paths. This tip comes from the fact that we have these kind of events that run both in server and on client natively. For example, one of the most events that you use regularly is begin play, for example. Begin play runs on both server and client for the simple reason that the client, say we have this actor that is replicated, that is spawned on the server, replicated to clients. This kind of actor will exist on both the server and the client, and that begin play will fire on both because event begin play fires after the actor is spawned. So sometimes we want some kind of way to filter these execution paths to say, okay, I want to do this kind of thing only on the server. I wanted to do this kind of thing only on the client, and this makes perfect sense to be able to filter server and client executions. So we have this game of Fortnite here. Probably if you're also aware of the client-server model in Unreal Engine, the way it works is that you have this two levels existing, one on the server, one on the client, running at the same time. Of course, the true game is only happening on the server. The client is making its best to simulate that game, and it makes sense to be that way, considering the server has its own last word in deciding things. So, for example, you could not end up in the client cheating or something. So on the server, we have in this first method we'll be looking. There's this way of filtering by net role, and by net role I mean this. There's two properties on every actor, one called local role and the other is called remote role, which you can use for this kind of case. So on the server, all actors will have this kind of role called local role, role authority, sorry. And this means you are able to know if the actor exists on a server by just checking that if it's role authority. Well, this is not always the case. This is not always the case. We'll see in a second why that's not. But if it happens to be role authority and the actor is replicated, then it's safe. You're safe to say, okay, this actor is its true version on the server. And on the client, our own local player will have autonomous proxy. The one we're controlling will have role autonomous proxy, and the other simulated players will have role simulated proxy, as you might have figured that out. And yeah, let's see this piece of code. So in Blueprint, what we do to be able to filter this execution server client execution paths is use these convenience macro called switch has authority. Also, again, notice that the target actor is replicated. And on authority, it means that the local role is authority. So there goes the server logic. On remote, it means that any other role, basically. So autonomous proxy, simulated proxy, all make sense. And then there goes the client logic. Well, this is again, local authority does not always mean that this actor exists on the server, for the simple reason that you could end up having local role of authority on the client. Say your example spawn explicitly an actor on client, simply for a visual reason. The server does not need to know about it. In that case, you want the local role of that actor will be authority, and it makes total sense considering that client is the one who spawned it. That actor will have the local role of authority, and that's why I always say use this when the target actor is replicated. It's not only when it's replicated. It should be also used in a specific point in time, which we'll look in a second. Okay, the second method is called to filter by net mode. So with net mode, we mean, for example, if we have like these two levels running, we'll have if the server is dedicated, then we'll have this kind of dedicated server returning for every actor. You should be aware that it's not the same as the role system, in the sense that in the role system, each actor had these local role and remote role properties, where in net mode is not a property anywhere. It's literally a function that you could call on actor components, for example, and it just goes back and chains back to the owning world, and the owning instance, game instance, just get the net mode from there. So if for one actor you have a dedicated server, it will be a dedicated server for all actors on that instance. Same goes for client. If it's client on one instance, it will be client for all instances, for all actors on that instance. So that's for the net mode. And if you're asking like when I should use which, or how I should be using them, so this is how I use them personally. Net mode, I use it in the earlier life points of an actor. So any point before begin play took place, I use the net mode for the simple reason that network roles have not been set up properly yet. And for net role, it's just like literally the other use cases, which is begin play and any point in time where begin play has already been called. So this is and probably I always prefer using the net roles for the simple reason that they are faster. But speaking of nowadays, this is much of a false worry. We have we do not have that potato bases anymore, and yeah, like something also to keep in mind that net modes, most of the time net modes are much reliable than net roles. So also something to keep in mind. Okay, so tip number 6: refraining from using delay to account for replication time. And with replication time, I mean the time it takes for an actor or an object literally to replicate. So you might have asked yourself, like, where does replication time come from? So it comes from several factors. One of them, the RTT, round trip time, also known as ping. Also the complexity of an object being replicated. So say, for example, you have this kind of an actor. It has several actor components, and within that actor components, you have several sub-objects there. So the more these stuff exist, the more the object will be more complicated and will take more time to replicate. Also, the replication settings are really important. We have already seen that table, if you remember at the start, where we've seen the net priority or the net update frequency, and the higher the higher the values, the less it takes time to replicate. And yeah, these kind of factors that you should be aware of. A very common example for this kind of an issue I keep seeing in multiple places is using, for example, is getting the player state in a widget blueprint. So say you have this widget blueprint of a score, which is just like literally displays the score for the player, and you happen to want to display the score when this widget gets constructed. So that's why we have this event construct. So what you would do is just like you would get the owning player, and with get owning player, what happens is that you get the player controller that owns this widget. You can notice that I'm using get owning player and not get player controller 0, which means that we are sticking to our tips. That's cool. And from then we are getting the player state, and you can see these two balloons, these two white balloons, which means that this property is replicated. So this player state will most of the time, when you do something like this, you will notice that stuff are not working correctly, and for the simple reason that this player state is not replicated at the time you do this. And you might ask like yourself, like, why this happens? But if you remember from that table, which I'm again referring to from the start of our talk, you notice that the player state had a very low net priority, also net update frequency, which means it will potentially take more time to replicate, which makes total sense for why it will be null in such case. Then the moment you realize something went wrong, you will see these kind of issues starting like the message log yelling at you, telling you, okay, you accessed this player state while it was null, and stuff like this. And at which point you would do the following, of course. You would use the delay node. And this is totally a bad hotfix. This is not something you would want to do for the simple reason that you have no idea of how much time that is going to be. It probably will take more than 0.2 seconds, and then again the code will fail. It will probably take less than that. Say you increase it to 2 seconds, and probably will take like only half a second. Then you are waiting for 1.5 seconds just for nothing, and just does not make sense. So you probably figured out this is not the way we should fix our problem, and the way we should fix it is being able, for example, to listen to this when this player state property gets replicated. Probably the easiest fix that I see people do is using event tech from the widget blueprint and just checking if the player state is valid or not. It makes sense. It's okay if you're prototyping or something, but for a real game scenario, you wouldn't do this. If you're a blueprint fanatic and you wanted to fix this issue, what you would do is go to the begin play of player state and go and filter the execution. So you go client side and just get the player state from there, which means the player state has, of course, replicated. That's a cool hack for blueprint people, but I wouldn't do it myself, of course. What I do advise you to use is the following functions. These functions, of course, also only found in C++. They are not exposed to Blueprint, sadly. And for example, you would listen, you have this unrep function when it gets called when the player state replicates. It's found in the pawn class. I guess it's much used than the one down there, than the controller's version one. For the simple reason, for example, you could be having this 3D widget of health bar for the pawn, for example, and you want to be able to listen to this health property that exists on the player state, for example, another valid scenario, and you would be waiting for this player state to replicate to then get the health property, the replicated health property from there, and just hook it up inside the 3D widget existing on the pawn. This is a really valid scenario, but you should keep in mind that these onRep functions, they only happen again when you are setting the player state. And this is not something, a player state is not a property that gets set frequently. It only gets set only in the start of the game, or when, for example, a controller is seamless traveling or persisting. So it's really specific scenarios. That's why you should be most of the time using this last method that is found there, onRep my property, which what it does is that it listens to. It's an onRep function per property. So for example, you have your health property, you just mark your health property with this onRep function, and you're able, if every time this health property changes, you're able to get that change and hook it up wherever you want and use it wherever you want. Okay, so tip number 7, know when is it safe to call RPCs. So RPCs are what I mean with this is that RPCs that are called in one instance of the game could end up being either absorbed, which means that they are not executed at all, or executed remotely. So they are executed in the remote instance, not where they called originally, or they could be executed locally. So they will be executed wherever they were called, or they could be executed locally and remotely at the same time. This last case is really valid, for example, for multicast RPCs, where they, for example, whenever they are called on the server, then they are executed also in the server and also on all remoted, not really, but they are executed potentially on clients. And this is a really valid case for multicast RPCs. So the first issue that happens in this case, if you're not aware when it's safe to be able to RPC from actors, is the issue where the RPC could be absorbed, and you would be getting a warning where it says no owning connection for the actor. This issue happens in the following cases where you have the server RPC and also the actor is not owned by a net connection. And with net connection, I mean it's kind of an object in Unreal Engine that is natively associated with a player controller. It happens at a specific point in time, and it basically means that this actor is owned by the client. So for example, the kind of actors, and of course, for sure, we would see this warning before in the output log. So we'd see telling you that there's no owning connection for that actor, and the function server RPC will not be processed. Again, this issue only happens, this absorbed RPC will only be happening for server RPCs. The other type of RPCs, whether they client RPCs or multicast RPCs, they will never be absorbed. They will always be executed. But in the case of server RPCs, they are potentially able to be absorbed. So the kind of actors that have net connection by default are player controller, player state, and pawn. This is the three actors that have net connection by default. Of course, player controller is the first one that gets that net connection associated, and it happens, and you are guaranteed to have that net connection at the time post login gets called from GameMode. And that means that you're safe to execute server RPCs whenever you want. And for player state and pawn, that happens whenever whenever function, for example, like postnet init or unrep owner gets called on both. And you might like ask yourself, okay, then why unrep owner is used in both in player state and pawn? And the simple reason for this is that the way a net connection is checked natively, there's a function called getNetConnection, and the way it works is that it checks it traverses the actor owners until it gets to an owner that has a net connection. And considering the fact that player state and pawn are owned by a player controller at specific point in times, they will have net connection, but again, at specific point in times. So I've put you here the functions that you are guaranteed to be having a net connection on these actors client side, which you can start server RPCing from these actors. So you might ask yourself, okay, then why am I not able to just like say I want to be interacting with an actor, just like literally a normal actor, not any of these actors that we're talking about. Say you have this kind of a chest in the world that you want to be interacting with it. You would ask yourself like, I could just like simply own that actor, own that chest, and I would be able to server RPC from that actor. Well, it might work for you on the short term, but it's not a really good practice for a couple of reasons. The first one is that you could end up owning too many actors, which will result in many unnecessary hard references. Well, hard references will go out of the scope of this talk. We're not going to be talking about them, but just know that it's better if you avoid them. It's better if exactly if they are not necessary, just like to keep away from them. And considering the owner is a hard reference, has a hard reference, the actor holds a hard reference to its owner, it's really good if you just don't end up like setting owner everywhere. It's also counterintuitive to polymorphism, which is perfect for this situation. You might like also ask yourself, okay, I might be able to interact with a chest. I also might be able to interact with a tree. I might also be able to interact with a table. So in this case, I should be owning all these actors. Oh, well, it does not make sense. And you could, what you would do in this case, you would have kind of a polymorphic function that exists in the native actors that we've already come to mention, player controller, pawn, for example. And if you make it polymorphic enough, you would be able to interact with whatever actor you want. And the third thing is that different clients wouldn't be able to interact with the same actor simultaneously. So this kind of reason is really valid. It's really good. In Unreal Engine, you're not able to have more than one owner for an actor. So whenever you have an owner, other clients cannot own that actor. And say, for example, you want to be able to have two clients interacting with an inventory or with a chest at the same time. You wouldn't be able to do this if you are owning that actor you want to server RPC from. So it does not make sense to own that actor. So what we should be doing instead? If these type of actors, we should not be owning them. They should not be having net connection. What should we be doing? So the thing is that we should be able to route the RPC in question, for example, the server RPC, through one of these actors that we come to mention before, player controller, pawn, or player state. They are enough for you to be able to use them. And a very common example that you would want to do in these scenarios is just press a key, an input key, to interact with an actor. That input key was just fire a server interact function, which is a server RPC, for example, that is found in either player controller or pawn, for example. And that server interact RPC would call a local function on this actor and on the target actor we are interacting with, called interact, and this interact function would be implemented the way you want. So for example, if you are interacting with a chest, you would do some kind of a behavior. If you're interacting with something else, and this is probably will be an interface function that you could implement the way you want on whichever actor you want. Okay, so the other issue that we would have under this category is the bad timing. So this issue goes over actors that should have no connection, but the point in time you are trying to use the RPC is not safe, which means that you're not having a net connection at that time. So these, for a very common example is the following. This is a blueprint. This is a blueprint class of character. You could see this if you look at the server RPC. It tells there that the target is PP third-person character. Of course, this is the kind of way that I read code for people. Because like sometimes they just take screenshots like this and just like you have to figure out which actor is this. So as long as that name is not misleading, you are able to know which target actor is that. And of course, this code is only for this demonstration purposes. You would never do something like this. Considering begin play is an event, as we already come to mention, is an event that gets executed both in server and on client. You would never need to do something like this. You would only need to just filter execution. Probably like a switch has authority and that's it. But just for our demonstration purposes, let's say like we are firing the server RPC from the remote execution pin, which means like we're on the client, we are trying to server RPC, so we could force an execution path on the server. And again, this is on the character. So this is wrong for a simple reason that begin play takes place before on character, of course, before that character is owned by a player controller, which means that that character would have a net connection. So begin play is an event that takes place very early, before the character has net connection, and that server RPC would simply be absorbed. Another very common example is literally the reverse. So in say you have this, again, demonstration purposes, you have this begin play, you are firing a client RPC from the server to force an execution path on the client. And in this case, we are on the player state, as you can see. The target is PP player state. And also in this example, the client RPC, what you would be saying, this is of course a wrong situation, for the simple reason that begin play on player state will take place before the player controller has a net connection. So to make it easier for you, again, player state is an actor that exists in Unreal Engine that is owned by a player controller. At this point in time, you are kind of guaranteed to have the player state owned by the player controller, but you are not guaranteed to have the player controller associated with a net connection. So it kind of chains back to the player controller and it finds it, but it's not able to find that net connection that is associated with the player controller. And for this simple reason, you wouldn't be able to fire this client this client RPC wouldn't be meaningful, meaning it wouldn't be able to execute on the client. And what would end up being happening here is that it would fail miserably. So another scenario that would happen, another issue is that local RPC. I chose to name it, which I would always say here, just logically decide if that point in time you are trying to RPC from is safe or not. And this comes again from the fact that are you able to read through source code, you are able to check knowledge sources and know about this stuff. But again, the example from before, say you have this this blueprint class of a character and you are trying to client RPC from the server. What you would see in this case, while you be expecting the client RPC to execute on the client, it will be executing on the server. As you can notice, it says server there, which means that this client RPC is taking place, is executing on the server, and that makes this client RPC literally meaningless. And the reason for this again is that that the time the begin play of a character gets placed, the character is not meant to be possessed. Most of the time, the character is not possessed by a player controller. And the way Unreal Engine works, every time the pawn is possessed by a player controller, it's automatically owned by that player controller. So considering that it's not possessed, it's also not owned, so it does not have a net connection. So this is also a wrong thing to do. Do not ever do it. Okay, so we can alleviate this issue again with our fancy delay node from before, but of course don't do it. We've already come to mention why that is the case. And what you should be doing instead in these scenarios is to use this BIEs, and with BIEs, it's a shortcut for blueprint implementable events that is already exist in Unreal Engine. Receive controller change and receive restarted, and the cool thing is that of course, they already, hence the name, they are found in blueprints, or you can find their native versions, and they are called every time the controller changes for that pawn, and usually that happens when a pawn gets possessed or depossessed or unpossessed by a player controller. So you can just like listen for these events and do whatever you want without even needing to RPC from these actors. The third issue is a lost RPC. So this problematic scenario I keep seeing from time to time. It happens again. You could read again under multicast tool compiler. The server says that the node says that the target is PP game state. This is an issue that I keep seeing in game state blueprint actor, where people tend to do is just go to the begin play event and try to multicast RPC from that begin play, and hopefully see that welcome being printed to all clients. Of course, that wouldn't happen. You would only, if you're looking at the output log, you would only notice that it only says server without any mention to any clients. And the reason for this is that this begin play on the game state happens much earlier than the client happens to connect to the server. So there's no game state existing for the client, since why this multicast won't be executed and would be lost in the first place for that client. So do not ever do this. You could be considering instead looking into the welcome player function that exists in GameMode. I would just leave it to you to look into it, or but just keep in mind that it's not as far as I know, it's not exposed to blueprint. Handle starting new player is exposed to blueprint, so you can use it. For example, moving along, we have this tip called "Do not call unnecessary RPCs." With unnecessary RPCs is a term I created for myself. That means these kind of RPCs that stem from the sad yet true fact that these of not being knowledgeable enough about the game framework multiplier-wise, which is a tip we have already come to mention. If you're not aware of how game framework objects operate and stuff like this, you will end up having these kind of unnecessary RPCs, and we've already come to see that this happens. For example, when we was client RPCing from the character on begin play. Again, we've said there's some other kind of nodes that we can use. The blueprint implementable event, for example, event receive controller changed, which you can just use it. Say, okay, I want to be able just to listen to when I want only to filter the client execution path. And in this case, it's really useful to kind of use this node called is locally controlled. And with is locally controlled is a function that only runs on pawns, and it means that this is the pawn that is locally controlled by this instance, so you are able to control it. So this means that we are at the local controller level. Yeah. Tip number 9, don't call meaningless RPCs. This is another term that I created, of course, for myself. And with meaningless RPCs, I mean RPCs that do not serve their true purpose. And with this, I mean RPCs that, for example, are being called somewhere and not executed remotely as they're supposed to do, or for example they are or even just absorbed, or I don't know, even just executed locally. So they do not, as simple as that, they do not serve their true purpose. And for example, this kind of and an example for this is a server RPC that gets invoked from the server. Of course, it does not make any sense. If you're in the server, you do not need to server RPC. You're already in the server. client RPC that is invoked from the server on a server-owned or even unowned actor. So we've already come to mention that you're only able to client RPC or server RPC from an actors that have net connection. And with having net connection, we already said that they are owned by the client. So if an actor is owned by the server, is unowned at all, you wouldn't be able to client RPC. You wouldn't be having the client RPC as meaningful. And for in this example, the client RPC, as we've seen before, it would be executing on the server instead of it being executed on the client. Not multicast RPC invoked from a client. With the way not multicast RPCs work is that they are supposed to be called from the server and then executed also on the server, also on the clients. Not all the clients. We'll see in a second in which clients we mean. But if you happen to invoke it from a client, it will only get executed locally on that client. So it becomes meaningless. Client RPC invoked from a client, of course, again, similar to the first. If you're on the client, you shouldn't be client RPCing in the first place. And even in much more extreme scenarios, they could even be dropped. Again, server RPCs, they are the only type of RPCs that could be dropped. And this happens when they are invoked from a client on a server-owned or unowned actor, which is something we've already come to mention. Okay, so tip number 10, differentiate reliable from unreliable RPCs. With this, I mean, with RPCs, of course, I mean replicated functions. They are called replicated functions. They are a shortcut probably for remote procedure calls. They are kind of an asynchronous calls where you are able, of course, to move from one side to another, from a server to client, or the other way around. And they can either be reliable or unreliable. It's kind of a tag or a setting that you are able to choose from. And by default, RPCs are unreliable, which is cool. Considering you could probably just have these RPCs out of their place, and if they are reliable, then in that case they would be problematic for you, which we'll see over in a second. Okay, so reliable RPCs. They are kind of RPCs that are guaranteed to reach their destination, hence since the name. Of course, and assuming that ownership rules are followed. So as we said before, with the ownership rules, I mean, if you're, for example, firing a client server RPC, the actor should be owned by a client, so ownership rules have to be followed, and also they are meant or they are guaranteed to be sent in the order they were sent. So the order is preserved, but that is a guarantee that happens as long as they are in the same translation unit. And with the same translation unit, I mean that these RPCs exist in the same actor. So you cannot just happen to server RPC from one actor and at the same time server RPC from, it's not only a server RPC, like whatever RPC, and RPC from another actor, and say, okay, because I RPC'd from this actor first, then it will happen first. It's not a guarantee right there, because they are different actors, and of course different actor channels as a result. And of course, because they are reliable, if they happen to not be acknowledged, they will keep being resent until they are acknowledged. And in some rare scenarios, for example, if you are having a really bad internet connection, so a packet loss for several seconds would only happen again in a very rare scenarios. These reliable RPCs will fail, and the client will be disconnected because they did not serve their true purpose. And since this guarantee, since we had this guarantee, of course, they will introduce more bandwidth and potentially latency to meet this guarantee. You should be avoiding, of course, sending these reliable events too often. It's like on tech, for example, considering they are always resent until they are acknowledged. There's no reason for you to be doing something like this, because there's kind of a reliable buffer where these reliable RPCs, if they are not sent, if they are not executed, if they are not processed, they are queued in that buffer. And if that buffer happens to get full or overflow, then the client will be disconnected. And something else that you should be using these kind of replicated events when the event is critical for gameplay. So say you have some kind of an event that should happen that could affect the state of the game. You should make sure that kind of event is reliable. And again, with those events should not be happening on tech, for example, on something like this. And And the other kind of RPCs are unreliable RPCs. Of course, as the name suggests, they may not reach their destination. They are unreliable, and they can even have gaps inside the calls. They are still guaranteed to be processed in order. But again, the fact that they would have these kind of limitations, just keep it in mind. And of course, this happen in case of a packet loss on the network, or if the engine determines that there's a kind of a net saturation happening or something like this. So it means that they won't be resent if they are lost. So of course, because they do not have such guarantees that the reliable RPCs had, they will use less bandwidth than the reliable RPCs. They can also be called safely more often. So in case you are calling it on tech, you can be doing something like this. Because they will simply be lost if they are not meant to be executed. And this kind of RPCs that you would use for cosmetic in nature events, so events that are not critical to gameplay. Say for example, you are spawning a visual effect or a sound effect. This is the kind of RPCs you want to use in such cases. So tip number 11, differentiate replicated properties from RPCs. This is the tip, probably one of the most tips that I keep referring to from time to time, which says like literally there are 3 golden rules in multiplayer should be living by. The first being using replicated properties for replicating stateful events. Of course, if something stateful is happening, you should be using replicated properties. It accounts in a lot of scenarios, which we'll see in a second. For example, if you have to happen in a late joiner, if your game happens to have supporting late joining, you would want to use, and you want that change that you did before someone joined. You would want to make sure that is implemented inside a replicated property, so it reflects for them, it accounts for them. The second rule is to use multicast or client RPCs to replicate transient or like a non-stateful events. And again, we've already come to mention this. Spawning visual effects, spawning sound effects is really perfect example for this. And the third rule is to use RPCs to make the client communicate with the server. And because basically this is the only way in multiplayer you are able to communicate with the server, to talk with the server, if you are the client, is to literally use server RPCs. And of course, something I would not forget to say is to almost always validate data. Because, for example, the client could be talking to the server telling him, hey, I have this health of 1 million, for example. And if the server does not validate this kind of data that is getting from the client, this would be really problematic and just would open room for a cheat or stuff like this. So always make sure you validate stuff. You have kind of a validate version functions that is again something that only exists something only exists natively in C++, does not exist in Blueprint. In Blueprint, you would need to do it yourself, kind of inside the RPC itself. You do not have kind of a dedicated function for that kind of stuff, where in CPP again you have. So just to keep in mind. And I always keep seeing people comparing between these two tools, replicated properties and RPCs, based on bandwidth and CPU performance. And in my opinion, this comparison is out of place for the simple reason that these are tools that literally serve quite different purposes. If you know this, you shouldn't be really comparing them based on these stats. But if you're really interested in knowing this kind of stuff, performance-wise, RPCs end up invoking much more functions and doing much more lookups, and whenever they are called, they are immediately executed, which is different from properties. Like replicated properties are batched at the end of the frame, which means that they will have more catch misses, of course, and this will have more. They will be more performance heavy. And some cool note at the end is to note that sometimes the use of RPCs could be useful or could be quite good for stateful replication, which is mind-blowing, I know. But sometimes you would want to use this if you happen to pass or exceed the maximum bunch size, which is around 64 kilobytes. In which case you would chunk your data inside RPCs and call these kind of RPCs, and make sure that you just combine these data on client and use it for whatever you want. But again, this is something that I wouldn't be doing too often. This is something that you would do again with the extreme caution, because like it could be really devastating if not used properly. Okay, so tip number 12: avoid game mode bad habits. So with game mode actor, I've seen too many bad habits, literally everywhere. So something to keep in mind: these all bad habits happen from the simple reason that people are not aware that game mode is server only. It only exists on the server, and of course it makes sense considering game mode is the one who dictates rules in the game. So it only exists on the server, and these bad habits are, for example, is trying to retrieve the game mode on the client and getting null, of course, and instead you should only do it on the server. Again, something else is filtering client-server execution paths, which is, of course, out of place considering game mode only exists in the server, so there's no meaning for us to be filtering these client-server execution paths. And number 3 is calling RPCs on game mode. Something I keep seeing literally people doing it everywhere. There's no reason for you to be doing RPCs considering you only have the game mode on the server. Of course, there's no other end, so there's no other end you are trying to move to. And also game mode is not replicated. RPCs are only you can only fire RPCs from replicated actors, something to keep in mind. And considering game mode is not replicated, you cannot call an RPC on it. Calling an RPC on it just like would be literally a normal function that is executed locally. There's no reason to do something like this. Okay, tip number 13: beware of multicast RPC myth. So currently, almost all sources of knowledge and multiplier will tell you the following piece of info about multicast RPCs, whether they're official sources or non-official ones. They will tell you the following. They will tell you that multicast RPCs are called on the server and are executed on the server and all connected clients. And people who read this, okay, they say, oh, that's amazing. Then I can just like literally call the multicast RPC on the server and make sure it's all executed on all clients. And that's not always the case. This is literally wrong because multicast RPCs do respect relevancy, for example. And with relevancy, I mean, we'll see in a second. So let's first correct this piece of info. So the correct statement is that multicast RPCs are called on the server and are executed on the server and on all connected clients. The actor is relevant to. And with relevant to, I mean, again, we've already come to talk about the relevancy system and how it works. So you should be aware that actors could be relevant to a client and they could also be not relevant to a client. They could be not relevant to a client for example, if they are really far away from that client. They could be not relevant to the client if they are hidden, for example. There could be there's a certain set of criteria that exist, and if the actor is not relevant to a client, then the actor would be literally destroyed on that client. It would still be existing on the server. It would still be existing on clients that the actor is relevant to, but that kind of actors that do not have the actor is relevant to them would have the actor destroyed in them, because there's literally no meaning for that actor to exist in the first place, considering it was spawned from replication. Of course, this is something that happens only if the actor is spawned from replication. If you happen to have a replicated actor that is loaded from the map, so it exists before runtime inside the map, this wouldn't happen. Even if the actor is not relevant to a client, it wouldn't be destroyed. So something to keep in mind. Of course, if you're aware of this, then you would literally change the way you think about these net multicast RPCs, as they literally respect relevancy, and exactly something to keep in mind. So this is the correct statement. Okay, so you have to be aware that net multicast or multicast RPCs won't account for either of the following scenarios. So the first scenario we've already come to mention is the join in progress clients. So if your game supports late joiners, the actor in question wouldn't be there in the first place, considering that client has not joined in the first place. And you wouldn't be able to have that RPC executing on that client. And we've already come to see an example where the game with the game state where we wanted to have this welcome string printed for clients, and it was not for listen for the clients, because at that point in time they wouldn't been joining. So even even if they were not there, like even if your game is not literally just like a join in progress, they were not, these clients were not there at that point in time, and since why that RPC was not executed for them, considering the actor was not there in the first place. So another reason we've already also come to mention is scenario is that clients the actor is not relevant for wouldn't have this multicast RPC executing on them. So say you have this kind of two players having two kind of pawns, and for the first player, you have this pawn executing a multicast RPC on the server, and this kind of the other player, say he's like really far away from the first player, such that the distance is higher than the netcall distance, which is a kind of a setting in one of the replication settings for every actor. And if that is the case, then that actor would potentially not be relevant to the client in question, since why the multicast RPC wouldn't be executing on that for that connection. And the third scenario is replay recording, which is something you would want to use, for example, if you are if you want to implement kill cams. And to handle, if you're asking how I should handle these scenarios properly, you would need to do stateful replication. Okay, so we've coming to an end. This is a bonus question before we end. You can just like literally just go on stage and answer. So my question is, can you spot what's wrong here? This is a screenshot I took from Unreal Slackers Discord. It's literally a real-time example that happened, and I would want you to answer if you're able. What went wrong here? So feel free to answer. Probably in chat you could also answer. Am I able to, or guys are not able to talk? Probably, yeah. Okay, so many things. Nice. Yola House says there's so many things. Can you just state what these things are? Client server connection, not ready at begin play. That's correct. There's no net connection at begin play. If you were reading through this, you would see like a control. It says controller, custom controller. So in this scenario, we are talking about the controller actor, and begin play happens takes place before post login from game mode takes place, which means we wouldn't be having a net connection associated with that player controller at that point in time. So this kind of client RPC would literally fail. That's cool. That's good. Nice one. Begin play sending an RPC to an only client and RPC being for sure. Nice one. Of course, that's probably the point I wanted you to notice. It's really cool. Also, yeah, the whole order of events is jacked up. Of course, that is also noticeable. Something you would also probably notice is the fact that the server RPC, you had the server RPC at the end where it has this switch has authority macro, convenience macro, and there's no reason literally to filter execution path if you're on the server. You're already in server. There's no reason for you to be saying, okay, I only want this to happen on authority. So it does not make sense at all. That's the points I wanted to make here, and yeah, that's it. Thank you for listening.
Really amazing talk. Thank you for presenting that. That was super cool.
Thank you so much. Thank you so much for listening.
I learned a whole bunch.
Feel free to ask if you have any kind of questions. Feel free to ask. This is the time. It will be available later. As far as I know, I'm recording it. I'm recording it. Thank you so much, guys. So I guess, someone's typing. No worries. Then I think probably we've come to an end. Literally feel free to ask any question you want. Is it safe to use on-tick commands for sending data? If you're if you mean is it a good idea to send data on tick? It depends what that data is. For example, we have happened to mention, for example, checking if something is valid on tick. That's something probably for prototyping I would do it. But if you're asking like sending data, I'm not really I'm not really aware of what that does that mean. But if you mean, for example, you are sending data that are on RPCing on tick, and that RPC, for example, is reliable, so you is kind of a reliable stuff, then you shouldn't be doing that, of course. If this is, for example, some kind of a movement for an actor, yes, you could be doing something like this. For example, you are moving, like sending exactly. Yeah. This is the thing that I'm referring to exactly right now. So say you are sending transforms every frame. Of course, you can do something like this, but just keep in mind that this has to be that the replicated event that you do should be unreliable. Just as simple as that. Yeah, no worries. Oh, Ben is typing. Thank you, Ben. Yeah, have a great one too. Yeah, your lighthouse is typing. It's probably a loaded question. Yeah, saying it's good to send unreliable RPC from client to server and then have the replicated variable. Yeah. Exactly. This is kind of a really normal workflow to have this kind of the client sending data to the server to let the server know about something that happened, something that we've already come to mention, an interaction, for example, something that happens, of course, first on the client, then gets propagated to the server, and then from there you would probably just do it like based on the context. You would have, for example, a replicated property or another server, a multicast RPC that gets propagated to the relevant actors to the client. So yeah, this is a really known and normal and acceptable workflow, of course, since relevance gets sent. Yeah. Yeah. Totally correct. No, I didn't got to talk about profiling network stuff. That would be crazy. Honestly, I didn't cover even. Yeah, I know. I didn't got even to talk about all the tips and tricks that I wanted. Probably there's around initially the article was released with about like 20 tips, and also only got to mention about like 12 of them. So I've left the one that is pretty complicated, just like for your own reading and for your own just like interpretation. But yeah, just like put those that I can just like cover as much as more in this hour. But yeah, just you can catch up with the recording, of course. Okay, are we done? I think so. Okay, so that's probably it. Thank you guys for attending. Thank you guys for listening. You are great listeners. Make sure you follow me on Twitter. Of course, I'm shamelessly advertising myself. And yeah, hopefully, hopefully it was a good talk for you. And I cannot also forget to thank Yo Lighthouse. He's one of my friends. He's also giving me tips of how I can deliver this talk to you as smooth as possible. So thank you a lot, Nicholas. Thank you so much, guys. Have a nice end of the day, and I'll see you soon. Bye.